Kevin Cole, PM Head of Cloud Management Solutions here at Supermicro, continuing our podcast on deploying a SuperCloud Developer Console as a VM instance. So we talked about this in a previous video, this nifty tool called Cockpit, which is now available with our CentOS 10 implementation of our hypervisor. So if you're familiar with CentOS 7, 8, previous CentOS versions, you had to deploy RDP as a desktop and then also deploy machine instance or virtual machine manager, excuse me, within your KVM hypervisor. So no need to do that anymore. We have this nifty tool here called Cockpit that is all centrally unified to allow you to build your virtual machines within a couple of clicks. So I'm in. I love the utility. I think it's great. And so hopefully you'll enjoy the utility as well. So let's dig into it. Let's get started. So first thing is we're going to log in as root. And you might want to probably log in with a different account that is privileged, not using root in your enterprise. We're in a controlled environment here in the lab, so it's very convenient for us to use root. So we'll put on our password here, and then we'll navigate directly over to the main dashboard here within Cockpit. So we already have some VMs already deployed, which are shards within our GPU tenant cloud that we're providing to our customers to evaluate. So we're going to start by doing a test developer console and go through the process. So the first thing is you need to decide, am I going to deploy it as a bare metal or am I going to deploy it as a VM, right? And of course, dependent on the type of hardware you have, you might be challenged to have to deploy as a VM, or if you have lots of hardware, then you can deploy as a bare metal. So your choice that is really dictated by your enterprise and what you have as far as assets within your enterprise. So the first thing we're going to do is look at our storage, right? So we did some navigation here in a previous video where we had our storage backend, which was two NVMe drives. So what's very, very important here is building basically an ISO repo where you have Ubuntu and other operating systems there stored as cold storage. You typically could use SAS or SATA or SSD drives there. Really no requirement, doesn't matter what you deploy there. Save your NVMe drives for storage pools for allowing your QCOW images to be stored in that storage pool. I can't emphasize this enough. When you actually are deploying SuperCloud Developer Console, where your QCOW images are stored in your storage pool is very, very important as an NVMe drive. If you use SAS or SATA or SSD drives, the performance is miserable. It's very sluggish. So definitely carve out an NVMe drive, large capacity to be able to support your KVM hypervisor, your CentOS 10 environment here. All right, so that's a little bit on our backhaul storage. Of course, you're going to go through in this CentOS 10 machine, make sure they're mounted, place them in FS tabs, do the best practices for UEID assignment within FS tab so you're not sort of surprised when your system boots and then all of a sudden you're thrown into maintenance mode, right? Because there's some confliction there. So important to make sure you do that ahead of time. And the other thing is when you're updating your storage pool itself for your drives, allocate where you're going to store your OS repo images and where you're going to install your QCOW images. Have a plan, right, of what you're going to do there. Okay, So a little bit about the backhaul storage there. So these are obviously physical drives that exist within your server. They may be connected to some type of backend storage pool. Maybe you're deciding to use other storage pool mechanisms and you're basically attaching this physical server to those software defined storage, or potentially it could be fiber channel, it could be NFS, it could be other types of mechanisms for your storage location. All right. So in our use case, we're using physical drives, a lot easier to work at in a lab setting that we have. All right. So the next thing we want to do is we want to look at going into the virtual machine place and creating a storage pool that we're going to carve out specifically for this particular developer console that we're utilizing. And what we do here is we click on the storage pool and it opens up those two storage pools. Right now, I already have a storage pool where I have storage volumes already allocated on my disk, which is an OS repo section. And then you can see here, shows the target path information here. And then also the storage volumes, which I have already there, 2 ISOs that are going to be mounted. Specifically, we're going to look at this one, which is Ubuntu 2204. And then we're going to basically deploy a VM instance with that particular operating system. All right, so that's the OS repo section. So now let's look at the VM storage pool. This is where you're going to store those QCOW images. Right now we've allocated 4, right? Because we have 4 VMs running. You can see here we've allocated 600 gigabit. The space there, or GB, sorry, gigabyte, sorry, not gigabit. The space allocates 300 GB, which is in the actual documentation. For future expansion, I recommend you double it to 600. So around 500, 600 should be adequate enough to be able to support your control plane for SuperCloud developer console. All right. So the first thing we're going to do is create a volume. And that volume is where, again, we're going to create this QCOW image format. In this case, let's call it dev console North America. Okay. And this is going to be your developer console control plane where you're going to import all those Kubernetes compute, and we're going to give it a 600 gig space to carve it out, and we're going to create it. And then at that point, we see here that it's already been allocated for 600 GB space. We don't have anything there yet because we haven't deployed an operating system yet. But you can see here, we've now created the volume. It's essentially allocated 600 GB space for that QCOW image or for that virtual machine. The next thing we're going to do is, after we've actually created the storage pool, let's review the networking itself, which is going to be important because, again, this notion of a bridge really is the electronic attachment of taking a vPort and connecting it to a VNIC, right? So that is a electrical signal within the software that allows those two to be tied together so you can forward packets out to your upstream switch. So this bridge we've created is 172.24.199.93. That's basically our host where our hypervisor is. We've created that bridge now. And we can click on the Add Bridge option, and you can tag a specific interface for the bridge. In our case, we've already done this. The bridge is created. You can see here packets are flowing here within this bridge by simply looking at the bridge. And you can see here traffic is being definitely passed between our upstream switch and also the VMs, right? So that gives you kind of an indication of, am I sending packets out there, right? So that could be helpful in troubleshooting and things like that. Of course, you would use a ping to your DNS server to make sure that you're able to ping it, right? And that you have physical connection. So sometimes if you can't ping it, it could be that there is an issue with the electrical signal between both the V port and the VNet. Could be an upstream switch problem. It could be you're not connected correctly to the right bridge. Many variables could be resulting in not able to ping your DNS, right? Could be a tagging issue. In our case, we're using access ports. So we're not getting into a lot of complexity as far as tagging and things of that nature. All right. So again, the network and of course, if you wanted to add VLANs, you can go in and associate those tag packets with the bridge or an interface by simply clicking here. We're using PVID 672, which is an access port to get out onto our corporate network and then out into the internet, which you're going to require later to be able to install Kubernetes using kubespray and some of the other Ansible playbooks that you need to actually run to be successful to create a control plane for SuperCloud Developer Console. Okay, enough of the babbling here. So let's dig in here and create our VM. So what we do is we come back here, and the first thing we're going to do is give it a unique name. And our name that we're going to call it here, just to be consistent, is Dev Console North America. Okay, so make sure you give a unique name and make sure it coincides with the QCOW storage pool that you set up or the QCOW image you set up. The next thing we're going to do is basically at this point choose from our media for ISO. That is going to be, we're going to choose local install media. What we're going to now do is do disk 1. So you simply type in this information and you can go to OS repo and then continue down and look at Ubuntu 2004. What's nice is it fills in the operating system here for you of 2204. And then make sure when you create your storage that you don't create it on the host, right? So you notice here we have 93.4 gigabyte or GIB, right, within this host. So the idea here is you want to use the storage pool, which is pointing to that NVMe drive, right? That you have a high capacity drive there for storing these QCOW images. So nevertheless, you should have an NVMe drive, probably 4 or 5 terabyte. And of course, if you're using this hypervisor for multiple use cases, that particular large capacity drive could be 14, 15, 20, depending on what your use case is for this hypervisor. So we're going to choose from the option of the storage pool. So VM storage pool, you can't allocate any of these volumes because they're already in use. We're going to use the drop down here of Dev Console North America. And then we're going to put the memory size in here of 6400. Make sure you change it here to this value. Okay. And then we're going to create and run. So it creates the VM, and then we can click here, and then we can see here by expanding here, we're ready to basically instantiate that VM. So you have to click in the window here. Sometimes if you're, it can be a frustration point here by trying to find out where your mouse is, you lose your mouse. So usually on the right hand side here, you can use the arrow to go up and down, and then at this point you are successfully deploying this relatively quickly to deploy it in a kind of environment where you're deploying as a physical server could take some time, right? Depending on how you're deploying and on that physical server. But for a VM, it's probably around 5 to 10 minutes. So we'll let this sort of cook in the background and continue with its install. Thanks for joining today. We'll see you on the other side.